Alright, this is the next step here is what we're going to call linear generalizing. And really we're going to do some substitution. We're going to see how to use a pattern and use a rule to generate some numbers, find some numbers, or solve for some numbers. In this case, Mrs. Chen, the principal of Grenville Public School, decided to buy these trapezoid-shaped tables, see here, for the school's new lunchroom. While Mrs. Chen waited for the tables to be delivered, she drew a plan for the lunchroom. She decided she would place 2 chairs on the long side of each table, here, or these 2, and 1 chair on every other side of the table, just like you see. In this way, 5 students could sit around each table. Then Mrs. Chen found that she could join 2 tables as shown. By joining 2 tables, 8 students could sit around them. How many students could sit around 3 tables joined this way? So I would kind of take that information out and I would just go ahead and draw for myself what 3 tables might look like. And then I would put in my chairs again. You may see the pattern already. You may have another solution to doing this, but that's what I would look at. And then if we count those up, we've got 11 chairs. Number 2 says how many students could sit around 56 tables going this way. So we probably don't want to continue drawing, but we do want to see the pattern here. So I'm going to put one more in. And one thing you could do is you could go right to creating table values here, right? You could see that for the when we had 2 tables, we had 8 chairs. When we had 3 tables, we had 11 chairs. And now we've created 4 tables, and if you count them up, we're at 14 chairs. You could look at that and you could start to ask yourself, what might the constant be? What might my multiplier be? How much am I going up by? You could also look up here. Right? We've got these 2 chairs on the side that don't go anywhere. When we had 2, 3, 4, there's always 2 extra chairs on the side. So hopefully, kind of by looking at that, you'll see that that's your constant, is 2. And then again, that increase, or that group of chairs that you have at every table, is this, is 3. Right? So let's see 3 here. So 3, in this case, is the multiplier. So that's important information to use to find this 56, right? I would actually jump ahead. I would kind of go ahead and answer question 3 at this point, and then we can get to the 56. So now we've got our information. Now we know that the number of chairs equals the number of tables times our multiplier times 3 plus 2 for the 2 on each side. And then once I get here, I would go ahead and put in my 56 tables and then work through the math. Times 3 per table plus 2 on the ends. 56 times 3 is 168. And then we have the 2 on the ends, and we get 170 equals chairs for 56 tables. But this, in the middle, is the rule we created that works for any number of tables. And we got that from this constant of 2. And we got that from this multiplier of 3. Number 4, though, the question is very different. This question says how many tables would be needed for 81 chairs? Would there be chairs left over? So now we can take this equation, number of chairs equals number of tables times 3 plus 2. We take this equation, now we can put in that we have 81 chairs. We've got our tables times 3 chairs per table plus a 2 on the end. So we got to kind of think back to ourselves, well, what do we do with this visual? What do we do with this diagram? And the first thing we want to do is get rid of these 2 on the ends. So we want to take away these 2 on the ends. And this is equation solving. We did this last year in math. So now we've got 79 chairs left, which is going to be our tables times the 3, right? Because each table had a group of 3 chairs around it. When we do this subtraction step, I should say here, this cancels, and instead of 81, we're left with 79 chairs. Now we just have to take that 79, we just have to break them into groups of 3, because every table is going to have 3 chairs around it. So we're taking our total chairs left, the 79, dividing by 3 now. And if you work that through, if you try it on your calculator, you'll see that we've got 29 tables with 2 extra chairs. Right, 79 goes into, or 3 goes into 79 29 times, so we've got 29 full tables. They will have a 2 on the ends, and we've got 2 chairs left over at the end. All right. Good luck with